Welcome to the deep dive. Today, we're venturing pretty far beyond the usual React query basics. We're going to get into the weeds, into the real performance challenges you hit with large React apps.
That's right.
If you're building those complex UIs, the ones where data's flying around all the time, you've probably felt the pain. It's often not the network call that slows you down, right? It's that avalanche of component re-renders afterward.
Exactly. Unnecessary updates.
So today we're honing in on React queries. Let's call it a precision tool for this exact problem, the select option.
Yeah, absolutely. And for you, the learner, especially if you're scaling up and hitting these performance walls, this is going to be super relevant. But quick heads up, select is definitely an advanced optimization.
Right.
If your app is small, maybe just starting out, you probably don't need to worry about this yet. But if you're dealing with what we call noisy data, where maybe one little piece of your API response changes constantly.
Like a live counter or something?
Exactly. Like a counter or comments or stock levels. And that forces components that don't care about that specific bit to re-render anyway.
Yeah.
Well, select can be a total lifesaver there. It's really about finding that balance, simplicity versus squeezing out performance.
Okay, so mission set. We're going to unpack how React Query actually manages its state, its subscriptions, then pinpoint why that default behavior can lead to over-rendering, and finally show you how Select lets you create these super fine-grained subscriptions to, well, basically sidestep those extra renders entirely. Ready to dive in?
Let's do it. All right, so to really get why Select is so powerful, we kind of have to back up and look at React Query's core mechanics, how it handles state. Think of RQ, React Query, as having this central hub for all the data it fetches. It's called the query cache, one global source of truth.
Okay.
Now, when your component uses the useQuery hook, it's essentially saying, hey, I'm interested in this specific piece of data. Under the hood, RQ creates something called a query observer for that component. Think of it like a dedicated listener for that data. And RQ is pretty smart about notifications. It doesn't just blast every update to every listener. It takes your query key, that array you pass in, and it hashes it. Creates a unique ID, a query hash.
Ah, okay.
And observers only get notified if the data associated with their specific query hash changes.
Which is why, like you said, my user profile component doesn't care when the product list updates, different keys, different hashes.
Exactly. That basic filtering works great most of the time. It keeps unrelated parts of your app separate.
And here's the kicker, right? This is where things get tricky in bigger apps. It's about the shape of the data itself that comes back from the API. Let's say you've got a query for product page, just one product. And the API endpoint gives you back this massive JSON object.
Everything about the product.
Right. And inside, you've got stuff that basically never changes. The product title, the main description, image URLs. Pretty static.
Stable data.
Yeah. But then you've also got fields that are jumping all over the place, maybe a live viewer count, or the latest comments feed, or stock availability that updates every few seconds. Real noisy data.
And that's the core problem. Imagine you have a tiny little component. All it does is display the product title, nice and static.
Okay.
It calls useQuery with the product's query key. So by default, what does it subscribe to?
The whole giant product object.
Bingo, the entire payload. Even though it only needs that one little title string, so the viewer count ticks up, or a new comment arrives, the underlying data object in the query cache for that product changes.
Its reference changes.
Which means RQ notifies all observers for that query hash, and your little title component, it gets the notification. And what does React do?
It re-renders, even though the title itself is exactly the same.
Exactly.
Clear.
It's burning CPU cycles for absolutely no reason, just because some other part of the data it's technically subscribed to changed.
So it's oversubscribed. It's listening to way more noise than it needs to.
Precisely.
And if you have dozens of these little focus components on a page, a button here, a price display there, the title, all using the same base query.
Yeah, they all re-render whenever any volatile part of that shared data updates. Your app performance just starts to tank.
Okay, I see the problem clearly now. It's inefficient.
It really is. We need a way to be more specific. To tell that title component, look, I only care if the title field changes. Ignore everything else. And, solving this fine-grained subscription thing is a classic problem. People used to build complex selectors manually, use memorization everywhere, or even pull in entirely separate state management libraries just to handle this.
Okay, so the state is set. We need surgical precision. Yeah. Enter the select option.
Exactly. Select is the tool RQ gives us for this. It's an option, just another property you pass into your useQuery configuration object. And what it holds is a function This function receives the full data that was fetched that big product object in our example. And its job is to, well, select or transform that data. You can use it to just pick out one field, like data.title, or you could grab a few fields and return a small object. Or you could even do some complex calculation based on the raw data.
And the key part is?
The key part is the component using useQuery only subscribes the result of that select function.
Ah. Not the whole raw data in the cache anymore?
Nope. Just the specific thing your select function returned. It creates that fine-grained subscription we were looking for.
So going back to our title component example, instead of just useQuery product, fetch product, and then using product query.data.title, we do useQuery product, fetch product, select.title.
Exactly. And now the data property you get back from the hook isn't the big product object anymore.
It's just the title string itself.
Right. So now think about what happens when the purchase count changes. The underlying product data in the cache updates. React Query reruns your select function internally. It gets the title. Let's say the title is still awesome widget. RQ compares that result, awesome widget, to the result from the last time select ran. Is it the same?
Yes, the title didn't change.
Right. So RQ sees no change in the selected data, and it blocks the notification to your component.
No re-render, even though the cache data technically changed?
Precisely. You've completely filtered out the noise from the purchase count updates. The component only cares about the title now.
That's actually really elegant.
It is. And it gets even better if you need, say, multiple stable fields, maybe the title and the description.
Okay, how does that work?
You just return an object from select. So select title, data.title, description.data.description. Now your component gets an object with just those two properties.
Okay, but wait. If the purchase count updates, the main data object changes reference. So when select runs again, it creates a new object titled, even if the title and description values are the same, isn't that a new object reference?
Uh-huh. Excellent question. You'd think that new reference would trigger a re-render, right?
Yeah, that's usually how React works with object comparisons.
But this is where React Query does something really clever. It performs what's called structural sharing on the result of the select function.
Structural sharing. Okay, what does that mean here?
It means RQ doesn't just do a simple check on the object reference coming out of select. It actually looks inside the object you return. It does a shallow comparison of the properties.
Ah.
So in your example, it checks, is the value of title the same as last time? Is the value of description the same? If both values are identical, even though the outer container object might be a new reference, RQ considers the selected data unchanged.
Wow, so it prevents the re-render based on the actual content, not just the object's memory address.
Exactly. It performs that stability check for you, comparing the structure. This is huge because it means you don't usually need to manually memoize the result of your select function just to keep the reference stable. RQ handles it.
That is a massive convenience. So select defines the slice, and structural sharing makes sure we only update when that specific slice actually changes content.
You got it. Components become much more efficient listeners. And, for all you TypeScript users out there, the great news is select plays really nicely with types.
Oh, good. How does that work?
It's pretty seamless, actually.
Okay.
TypeScript is smart enough to look at your select function. It infers the return type of that function, whether it's a string, a number, or that small object we talked about. And then the data property you get back from useQuery is automatically typed correctly to match whatever your selector returns.
Nice. So if my selector returns data.title, then useQuery.data is typed as a string. If it returns title description, data is typed as that specific object shape.
Exactly. Type safety is maintained throughout.
Yep. Okay, but this sounds like it could get tricky if you're trying to build reusable query logic. Like, say I have a helper function, maybe useProduct, product by dit. That wraps useQuery. If one component using useProduct needs the whole product data, but another component using the same useProduct hook only needs the title, how do you handle that? Adding select changes the return type.
Yeah, that's a really good point. It brings up a bigger architectural question. How much should you abstract?
Right.
Honestly, the simplest and often the best approach, especially with the newer Query Options API in RQ, is often to keep your reusable part focused just on the core stuff. So your reusable function or object might define the query key logic and the query fen, how to fetch the data.
Okay.
And then the select option, you define that right where you use the query inside the component itself.
Ah, so the component decides what slice it needs. The shared logic just provides the base query.
Exactly. It keeps the abstraction clean and avoids complicated TypeScript gymnastics trying to make one function return multiple possible data shapes based on an optional selector.
That makes sense. Avoid the complexity if you can. Define the specific need at the point of use.
Precisely. Now, if you really must create a reusable hook that can optionally accept a selector, it is possible with TypeScript generics. You have to add a generic type parameter, maybe like tSelectData, that defaults to the full fetch response type. Then you type the select option to return tSelectData. It gets involved.
Okay, yeah, let's maybe not dive too deep into complex generics here. The takeaway is prefer defining select where you call useQuery.
Yep. Keep it simple where possible. Let the component specify its data needs directly.
Okay, so select solves the noisy data problem brilliantly. But what if the transformation itself inside select becomes the bottleneck? We're not just picking data.title anymore. Imagine select is running some, expensive super transformation.
Like calculating complex stats, maybe an average rating across thousands of reviews, filtering them heavily, sorting them multiple ways.
Exactly, something that actually takes significant CPU time to compute.
Right. Now we have a different potential performance issue. We need to think about when that select function actually runs. Our queue runs select mainly in two situations. One, when the underlying data fetched from the server changes. That's expected, right? You need to recompute based on new data.
Sure, nothing.
But two, it also reruns if the select function itself changes, specifically if its reference changes. Our queue does this check for optimization.
And if I define that expensive super transformation function inline inside my React component.
Then React creates a brand new function reference on every single render of that component.
Oh.
So even if the underlying product data hasn't changed at all, if your component re-renders for some other reason, maybe unrelated parent state change, that inline selector function gets a new reference.
Which makes React Query rerun the expensive transformation.
Exactly. Even though the input data is identical, you've just swapped unnecessary network-triggered re-renders for unnecessary CPU-bound calculations.
Okay, ouch. So how do we fix that?
Solution number one is about making that function reference stable. And this is where React.useCallback actually shines. It's a perfect use case.
Right.
If your expensive selector function depends on something from the component, like maybe a prop min rating used for filtering, you absolutely need to wrap the entire selector function definition in useCallback, like concepts select product stats, React.useCallback, min and rate rating.
And put min rating in the dependency array.
Crucial. Put min rating in the dependency array. Now, the select product stats function reference only changes if min rating changes. Otherwise, it's stable across renders.
Okay. And if the selector doesn't depend on any props or state, if it's just pure computation on the data?
Even simpler. Just define the function outside your component altogether. Top-level module scope. Then it has a single permanent reference. No useCallback needed.
Got it. Stabilize the reference either with useCallback if needed or by moving the function out.
Yep. That solves the problem of the function running unnecessarily just because the component re-rendered. But there's still one more level, the final boss of selector optimization, if you will.
Uh-oh, what now?
What if you have multiple components on the same page, all using the exact same query key and the exact same stable but expensive selector function?
Like 3 product cards, maybe? All showing the same complex computed stats for the same product?
Exactly. Remember how useQuery creates a query observer for each component instance?
Yeah, 1 listener per component.
So 3 components means 3 observers, even if they share the query key and selector. Now, when the underlying product data does change, React Query runs the select function once per observer.
So if the data updates, that expensive calculation runs 3 separate times.
Bingo. Once for each component. Even though the input data and the function were identical for all 3, that's wasted computation. We really only need it to run once.
Okay, that's definitely not ideal. How do we tackle that? We need to share the result of the computation across those observers.
Exactly. This calls for external memoization. We need to cache the result of the expensive function based on its input outside of React Query's per observer execution.
So like using a dedicated memoization library?
Precisely. Libraries like fast-memoize or memoize1 are perfect for this. You take your expensive super transformation function and you wrap it with the memoization library before you even pass it to React Query. Let's say const memoize transformation fast memo expensive super transformation.
Okay.
Now, your stable select function that you pass to useQuery simply calls memoize transformation data.
Ah, I see. So what happens when the data updates now?
Okay, component 1's observer runs. It calls select, which calls memoize transformation with the data. The transformation runs, calculates the result, and fast-memoize caches it against that input data.
Right.
Component 2's observer runs. It calls select, which calls memoize transformation with the exact same data. Fast-memoize sees it already has a cached result for this input. It skips the expensive calculation entirely and just returns the cached result instantly.
And component 3 does the same, hits the cache again.
Yep, hits the cache. So the select function provided to useQuery still runs 3 times, once per observer. That's unavoidable RQ behavior. But the actual expensive work inside it only runs once. The other 2 times leverage the shared external cache.
That's the ultimate optimization then. Memoize the heavy lifting outside of the select function itself.
That's the final piece for really complex shared computations. Hashtag tag outro.
So let's kind of wrap this all up. The big takeaway here is that select is your go-to tool in React Query for creating those fine-grained subscriptions. It directly solves the performance drag from noisy data causing components to re-render when they don't need to.
Right. Step 1. Use select to pick only the data you need. Leverage structural sharing for object selections. Step 2. If the selection involves heavy computation, make sure the selector function reference is stable. Use callback if it depends on prop state, or just define it outside the component if it doesn't.
And step 3, the final boss. If that stable, expensive selector is used by multiple components for the same query, wrap the core expensive logic with an external memoization library like fast-memoize.
You've nailed it. That's the progression from basic selection to advanced performance tuning. And maybe this leaves you, the listener, with a final thought to chew on. We saw how good structural sharing is when you're just selecting a few properties. It handles stability really well. External memoization, like with fast-memoize, adds another layer of complexity, another dependency. So the provocative question is, given how well structural sharing works for basic selections, how often is the extra complexity of external memoization really necessary in practice? Is the performance gain from preventing that duplicate computation across observers truly significant enough in your specific app to justify adding that external library and the memoization wrapper? Or is just ensuring the select function itself is stable often good enough?
A question of pragmatism versus perfection, maybe. Always profile, right?
Always profile first. Don't optimize prematurely. Find the actual bottleneck, then apply the simplest tool that fixes it effectively.
Great advice. Well, that was quite the deep dive into React Query Selectors. Hopefully that gives you some powerful tools for your own applications.
Hope it was helpful.
Thanks for tuning in. We'll catch you on the next deep dive.